Okay, in our first problem here, I want to just do mole conversions for the three types of problems that we are going to encounter. And this one we want to know how many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium. So again, you want to always write down what your known is. So write down the 1.25 times 10 to the 23rd atoms, and that's magnesium. Alright, and then like I said, I use the T-chart. That's simply an organizational tool, but if you wanted to do it by times, feel free to do that. So this one I'll do times. Now, look on your molehill that I gave you in class, or if you don't have it, you can download it from the website. And you'll start at the atoms, the MIAs. Alright, this happens to be atoms. That is what we want to get rid of. So that will go in our denominator. Alright. Think about it. If I had atoms in the numerator and moles in the denominator, then when I multiply 1.25 times 10 to the 23rd atoms of magnesium times atoms of magnesium, I'm going to get atoms squared per mole. And that's not what we want. So you want to be able to end up with what you desire. And in this case, we desire moles. So I'm going to put my atoms on the bottom, and our conversion factor is Avogadro's number, and that would be atoms of Mg, and that's for every mole of magnesium. Now you can see that our atoms of Mg will cancel out and we're left with moles. So when I do the math on this, I get 0.208 moles of magnesium. Now remember, that's 3 sig figs. We began with 3 sig figs. We do not count conversion factors in consideration of our number of sig figs. So 9 out of 10 times it'll be simply what your known is will be the number of sig figs that you have. So 2.208 is indeed 3 sig figs. It makes sense. Alright, we wouldn't expect to have a huge times 10 to the something. So if you got times 10 to the 46, then check your math. Check your math. Alright, because the way you would put this into your calculator is 1.25 and then hit your E button. Sorry, I shouldn't have circled that 23. But that E stands for the time 10. And then you put in your exponent, which this case is 23. And then down here, your E button is the times 10. So we'd put 6.02 E 23. Now you got to find your E button. I know on the TI-83 it's the second comma. For the other ones you'll have to find that, and if you can't find it, let me know. I'll try to find it in class. Okay, our second type of problem here is we want to figure out how many moles when we are given a gram quantity. So nothing new under the sun. I'm still going to write down what I know. Alright, in this case we have how many moles of iron 3 oxide, which is rust, are contained in 92.2 grams of Fe2O3. So again, I'm going to write down what I know. I know that I have 92.2 grams of Fe2O3. Alright, I'll use the T-chart in this case, just like the multiply, like I did in the last example. And what I use next is the molar mass. And molar mass is simply the grams of the substance that you get from the periodic table in grams per 1 mole of that substance. So for example, in this case we have Fe, and we have 2 of them, and we have oxygen, and we have 3 of them. Well, Fe for each of those, it's 55.85 grams. And that comes out to be 111.6 grams of Fe. All right, now I have 3 oxygens. They each clock in at 16.0. And that would give me a total of 48.0. It's good to round to the tenths when we're taking our atomic weights. So that's 159.6 grams of Fe per mole of Fe2O3, excuse me. We added it all together, so we would have 159.6 grams of Fe2O3 per mole. That's our conversion factor. We're going to use that. This is what we call our molar mass, which I frequently use 2 capital M's, molar mass. All right, so I'm going to erase that molar mass so we can now fit it into the equation. Whenever I say molar mass, or whenever you're looking on your molehill and you see that you need to convert to grams or from grams to moles, and you go by that conversion factor on your molehill called molar mass, immediately think periodic table, because you're going to have to consult the periodic table in order to get that. Now I want the grams to cancel, so what I just added up, my molar mass, I'm going to put that at the bottom. So it was 159, I believe, 0.6 grams of Fe2O3 for every 1 mole of Fe2O3. My grams cancel, and I do the math on this. So I take 92.2 times 1 mole of Fe2O3 divided by 159.6. And I end up with 0.578 moles of Fe2O3. See, now this is the beautiful thing about these conversion factors, is you can flip them any way you want to enable you to cancel the appropriate units. So feel free to flip that if you were trying to cancel moles, for example. All right, this case we're trying to cancel the grams, so we want moles on top. 1 mole is equal to the atomic weight of whatever you're talking about added up on the periodic table in grams of that substance. Alright, so this leads us to the last type of problem that you will encounter. Okay, our last problem determines the molar volume. Now the key there is that it has to be at STP, which is standard temperature and pressure. And for gases, when we're talking about gases, which we are, standard temperature and pressure is 0 degrees Celsius and 1 atmosphere. And that'll be more important when we get into gases the second semester. Alright, but now just make sure that whatever the problem is, it gives it to you in STP so you can use the molar volume of it. Alright, so this one says determine the volume in liters of 0.60 moles of SO2 at STP. SO2 is sulfur dioxide. It's air pollutant. And of course, one of the causes of acid rain. Alright, You'll see a lot of that in California. All right, so we want to determine the volume in liters of 0.60 moles of SO2 at STP. So again, I'm going to write down what I know. So what I know is that I have 0.60 moles of SO2. And I want to get it into liters. So I need to, again, whatever I'm given, that's where you start on your molehill. So in these cases, these are simple one-step problems. And we've been starting at moles. So I'm starting at the top of the molehill. In this case, I'm going straight down, because that's the one that goes from moles to liters at STP. And I'm at STP, so I make that requirement. I fulfill that requirement there. So then I take a look at the conversion factor, and you'll see that it's 22.4 liters of whatever gas we're talking about is 1 mole of that gas. That was Avogadro's hypothesis, that 1 mole of any gas at STP and constant pressure will contain the same number of particles. All right, in this case, the particles being Avogadro's number, 6.02 times 10 to the 23rd. So I use that conversion so I can cancel out moles. Well, I know 1 mole of SO2 is 22.4 liters of SO2. That's my conversion factor. Again, I'm not counting it in my sig figs. So I know that I'll have to have my answer end up with 2 sig figs. In fact, what I frequently do is I seek out what my known is in the problem, and I put 2 sig figs. So I know that that's what I have to report my final answer on, is 2 sig figs. So in this case, my mole of SO2 cancels out, and I simply do the math. So in this case, it's 0.60 times 22.4 liters, and that equals to 2 sig figs, 13 liters of SO2. Now this intuitively makes sense, because this 0.60 moles is about half a mole, and we know that 1 mole is 22.4. So a half a mole would be 11.2. All right, well, we got a little more than that, so 13 liters makes perfect sense, and that's a good way for you to check yourself. All right, I'm going to give you one other example where we're going 2 steps. Okay, the last problem here is just a 2-step problem. You'll do all of them the same way. So no matter where you start, if you start at grams, liters, or atoms, molecules, or ions, or whatever we're talking about, you'll start the same way. In this case, we have 82.0 grams of propane, C3H8, and we want to calculate the number of molecules of propane that you'd have. So, again, there's nothing new that you want to do. You just simply want to put down what your known is. So, if all else fails, put down what your known is, and C3H8, which is a hydrocarbon, propane. We're all familiar with that. It cooks our hamburgers and hot dogs. All right, so now on your mole math, if you start at the grams and you move up to moles there, you pass by the molar mass. And the molar mass makes you think immediately of periodic table, because you're going to have to add up the masses, the atomic weights of the substances that you're talking about. Well, carbon you have is clocks in at 12.0. Let's take it to the 10th. You have 3 of them. And our hydrogen is 1.0, and we have 8 of them. So this will be 36. This will be 8. So the molar mass of our C3H8 is equal to 44 grams per mole. There's our conversion factor. All right, so what I'm going to do is put the 44 grams at the bottom and 1 mole at the top of for my propane. So our grams cancel out. All right, and you can see what we're left with is mole. All right, now if we're asked in the problem, moles of propane, boom, we're done. No mass. All right, but we want to know how many molecules, so we need to go one step further. All right, so you're at the top of your molehill right now. If you go down your molehill, you'll see that we want to go over to the MIAs, the molecules in this case. Okay, the molecules. So we know that 1 mole of C3H8 contains Avogadro's number of molecules of propane, which is 6.02 times 10 to the 23rd molecules of C3H8. Now that's how I abbreviate it, but just be careful, all right, because that C can easily turn into an O if your handwriting is as atrocious as mine, so that can easily be misconstrued for moles. So just be careful of your abbreviations there. All right, so then what I do is I take 82, punch that into my calculator, times 1. All right, because now our moles cancel. Moles of C3H8 cancel. We're left with 1. So 82 times 1 times 6.02 E, my E button, 23. Okay, it's not times E. Don't think that. It's not caret E. It is simply E. It'll either be EXP or double E on your calculator. Okay, again, if you're having troubles, let me know and I will find it for you. All right, so when you multiply that out, we want to report it to the correct sig fig. So right here I have my known quantity here. That's 3 sig figs. So I want to report my answer to 3 sig figs. And when I do that, it's 1.12 times 10 to the 24th molecules of propane. All right, so I hope this has helped you a little bit. Let me know if you'd like some more practice ones. I can get some made and put up on the website for you. And let me know if you're having any problems with this, because we're going to be using this throughout the year.